Greetings, peeps. We're back in the office looking at average velocity. All right, so we've studied displacement and we incorporated a little bit of velocity most recently. So now we're going to formally define what average velocity is, and we're going to run through a couple of cases that will demonstrate how to calculate average velocity using a displacement versus time graph, those cool things we just created in the lab. Average velocity is displacement versus the time interval. So it's the displacement over that time interval. And mathematically and symbolically, it looks like this. This is notation taken directly from your text. And what we have here is V with a little arrow, and that arrow, as we can see, signifies arrow atop a variable means vector quantity. And the bar atop the V and that arrow means average. So that bar signifies average. So we call this V bar, which is a vector quantity, is equal to delta D over delta T. The delta is a Greek letter that signifies change in. So it is the change in some kind of quantity. We know it's going to change from one value to another. And what we have here is the change in actually means you have D minus D naught over T minus T naught. And the change in is from one value to another. So the D is wherever we end up, wherever the displacement is, versus D naught, your original position. It could be actually the origin, or it could be the last position which you started, which is why we did the activity out in the field, and the signs that read 10 meters, 20 meters, negative 10, negative 20 meters. We did that activity to do that both ways, so that naught could be relative to the origin, or naught could be relative to your last position. T minus T naught, so it's just the time interval, whatever time we're at versus the original time that we started this movement, okay? Now, time is a scalar quantity, which is why it doesn't have the arrows. It doesn't have the arrows because, well, essentially time does move, but it's in one direction. The arrow time is always forward. So we just consider that to be a scalar quantity. There wouldn't be a negative time. We can't go backwards in time very easily, not yet. Although the equations of Einstein say maybe that's possible in some certain cases, but not right now. Anyway, in our physics, time is a scalar. So, average velocity. Let's look at a case. We have a displacement versus time graph. It's a simple graph where we start off at the origin and the motion is constant, and that will end up at 10 meters over 5 seconds. Okay, so we're going to calculate this out and see what the velocity is. Well, we've got the definition up here symbolically. V equals delta D over delta T, which is D minus D naught over T minus T naught. This, by the way, this quantity here, if you haven't recognized it already, is the slope. It's the rise over the run. The rise is the y-axis, which is represented by D, and the run is the time axis over here. So it is D over T, absolutely. All right, let's do this for Nini knocks over the sign. Silly girl. All right, come on. And what I'm going to do is actually assign these values. So I can drop the pointer. V equals D minus D naught. Okay, well, where's D? D is 10 meters. That's the displacement. So I'm going to put 10 meters in here. Minus D naught. Well, where did we begin? We began at the origin, position 0. 0 meters goes here. So, now that's divided by T minus T naught. Well, how much time elapsed in that interval? Well, when we were at position 10, 5 seconds had elapsed, okay? So we're at T equals 5 seconds. So I put 5 seconds down here, minus T naught. Well, what time did we start? When we began the stopwatch. 0 seconds. 0 seconds. So what we have is 10 minus 0 meters over 5 minus 0 seconds for 2 meters per second. Positive value. So that's how we find average velocity in this case over here. We're going to run through another quick case that's slightly different. Here we go. What we have is a graph, very similar. It's displacement versus time. The second one begins at position 10. It's where we left off. Maybe we hung out for a little while, and we're starting some motion. Although, notice here, at 0 seconds, from 0 to 5 seconds on this particular graph, it's flat. There's no motion. We begin at position 10. We end at position 10 from 0 to 5 seconds. A flat 0 slope means no motion. It means the velocity is 0 meters per second. So here, the time from 0 seconds to 5 seconds is going to reveal a velocity of 0 meters per second. So that means we need to figure out what the velocity is when motion is taking place. And that is from 5 seconds to 10 seconds over this interval here. Notice we're beginning from position 10 and going to position -5 past the origin. So that means a couple things. That means our position will be negative, but also because the slope is slanted in this direction, it means we have a negative slope and a negative velocity, which means that we are moving in the negative direction. So as you can see, we're getting more negative as the slope moves downward. So the calculation is the same process, but we expect, though, because the negative slopes get a negative number, and so we'll see. So V equals delta D over delta T. We've established this, and that's D minus D naught over T minus T naught. Well, what is our D? Okay, we end up at -5 meters. So here, V equals -5 meters for D. Where did we begin? Minus this spot over here where we began, that's 10 meters. So this is -10 meters over the time interval, okay? Well, how much time was on the stopwatch when we ended? 10 seconds. So 10 seconds goes over here minus T naught. T naught is 5 seconds. We began at 5 seconds. Now, it's clear to see that the interval of time is 5 seconds. 10 minus 5 is 5. We can kind of figure that out. I'm just going through formally with the definition so you can see how this works. So now let's work this out. -5 minus 10. Well, that's the same thing as plus -10 meters. What we have here is -15 meters over 5 seconds. And so clearly what we see here is that the answer is -3 meters per second. That's the velocity. We got our negative number. It all worked out just fine. All right. So it is Morad Nini out.